I hope you can see my screen well. You all have seen so many cool things done with ROS. But the most important thing, whether you can do something like that on your own, whether you have the sufficient budget to do something like that, whether you can include that in your projects, you are going to do that later. So that is the main problem we should address. So how to interface your custom robot using ROS? So what do I mean by a custom robot? It can be something very simple in hardware, like you have a Arduino, you have attached a servo to your Arduino, and it will be a servo is something like you'll be giving a PWM signal or voltage signal through your Arduino, and it will move to the given angle. The shaft will rotate to the given angle using that PWM signal. So it can be something very simple in hardware like that, or this is a robot. This is a Hexapod robot uh, called Weave, and you can see each leg has 1, 2, 3, 4, 5 servo motors alone, and there are 6 legs. That means there are 30 servos altogether. So this robot is fully running on ROS and simulated using Gazebo. So you might be surprised that you can interface your custom robot, even if it is something very small like this, or even if it is very complex like this, using ROS. So let's see how we can do that, starting from the very small example. So this project in the left hand side, it doesn't mean it is actually simple one. Even though it is simple in hardware, it can be extremely complex in control system wise. So nothing is like a simple project in robotics. So the first most important thing is computational power. What is the best for you? So if you are developing a robot like this, you might have to use an Intel Core i7 based processing power. In this robot, there is a board called Intel NUC, which is something like a mini PC. So you'll need a big computational power to handle all the things like vision and everything in such a robot. But if you are using a simple project, then you don't need to go higher. You can use something very simple as Arduino. So the main thing is, if you don't need a computational power, you don't need to interface a big processing power unit, because it will consume lots of power, and you cannot of course run these algorithms, complex algorithms, in smaller pieces. So first thing is, you should understand what is the best computational power for you, and according to the budget. And you can decide what is the platform you are going to use, whether it's Arduino or a Raspberry Pi, or very complex. If you are doing something complex, whether it's an internal, then you can decide how you can interface ROS into that project. So how you interface will be slightly different, but will be same in overall architecture. So let's start from the very beginning of the ladder. So you are controlling a servo motor. You are using Arduino. So what is your setup? You have Arduino. You have connected it into your personal computer using a USB port, say a USB cable, and you have correctly wired your servo motor. So the PWM comes to the Arduino, and you have a variable resistor or potentiometer to map the rotation in this potentiometer into the angle in this servo motor. So you can just Google and get the script and run it, and you can see how it is going on. So this is like a very simple Arduino project that everyone can do. So let's make it a little more advanced. So instead of one servo motor, you have now 4 servo motors. So let's assume you have some 3D printed something, or you have attached them in some kind of manner. So this is a gripper, and there are 3 joints here. So all the servos are mounted there. So what happens? All you have to do is, rather than one PWM output, you need 4 PWM outputs. So the Arduino and how you interface it does not change. So a servo arm, a robot arm with 4 degrees of freedom is like a pretty good project. So but you are still using controlling it using Arduino. So is that what you all can do? No, you can do much better. So here you'll have to rely on something simple like the serial monitor in Arduino to control, or you can include algorithms inside here. But it is not that much intuitive because it is kind of like a limitation in this Arduino based ecosystem. But if you can interface ROS, what you can actually do, let's see what you can do. So the most important thing, you don't need to upgrade your hardware. It is exactly the same. What you have done is we have converted this Arduino Uno into a ROS node, and you are now connecting into your ROS running laptop through the same manner. But instead of like serial communication, now the communication is happening. It's still the serial communication, but the the way we see it, now you are issuing commands as ROS topics. So you will have a ROS master running in your laptop. And what you can do more, in previous sessions, Kitmin mentioned how you can create your URDF file or the visualization file for your custom robot. So you can do that, and you can have real-time visualization. That alone is a really good thing. If you can see in your laptop screen how your robot behaves, that will be pretty cool. And you can teleoperate from your keyboard and mouse. Yeah, there are so many ROS nodes available for that. And another important thing is you can perform simulations in absence of the real hardware. Like for example, uh, in this COVID situation, maybe you can't get together as a groups and do some projects. So instead, you can have a gazebo simulation, and all of you can work on that project remotely. So there are so many possibilities, and of course, you can test your algorithms before you run in your real robot. So those things are very easy, and you can learn them very fast. So also, if you are familiar with C++ or Python, then you can implement your algorithms using them. Or you can use, as Sakuna mentioned, state-of-the-art open source trajectory planners such as Move It to control your robot. So you don't have to worry. You can do much more advanced motions, even though your hardware is just the same. So it is kind of like, if you see it here, if you see the capability of Arduino and if you see the capability with ROS, it sounds like very advanced, but absolutely not. It is not that advanced. You can do very simple changes, and you can convert your Arduino into a ROS node or a ROS subscriber and a publisher. So first thing you have to do is install ROS serial package in your ROS environment. So basically you can do it with two lines in terminal. And just like when you are interfacing a sensor to your Arduino, you'll have to download a library and install it in a folder. Just the same way, you can download the ROS serial library package, and you can include it as a library in your Arduino environment. And finally, you have to change your Arduino code a little bit. So this is the Arduino code that would usually go in Arduino. So instead of like uh, doing it normally, first you include a small line, include ROS.h, and now it will have all the ROS capability, and you can define this as a publisher, subscriber, or both, and it will be a full ROS node. So that is very easy, and everyone of you can learn that very easily. And as a summary, let's assume that you have converted your Arduino into a ROS node. So let's see as a summary. So your laptop will be running the ROS master, and there will be custom C++ or Python ROS node handling all your commands. So you'll have your algorithms written in C++ or Python, or else you can use GUI based visualizations, or you can use the Move It environment as Sakuna mentioned. So anything can give commands in this ROS environment, and it will be very easy to interface any other node, any other uh, custom nodes, or any other nodes. So the Rostopic will be published in sensor messages / join state special Rostopic type. So inside that, you will define what are the values, join what is joint one value, joint two value, joint three value, and joint four value. This is like the basic structure of a Rostopic. And when you publish it like that, it can be easily subscribed by this ROS node running Arduino. And it inside Arduino, uh, all you have to do is convert the joint one angle into the PWM signal one, and joint two angle into the PWM signal two, and so on and so on. So according to PWM signal one, the servo corresponding to that will turn the necessary rotations, necessary angle. And also, because this topic is published, RVs can easily subscribe to that ROS topic as well. And because of that, you can real-time visualize how you what are the commands you have published, and what is the current configuration of your robot in your laptop script. So overall, it seems pretty cool. And of course, the most important thing, this only needs an Arduino and four servers and some method to connect them. And so it is not that budget expensive either. So if you are interested, you can start using ROS and learn much more. So you can learn about ROS master, ROS nodes, ROS topics, visualization, simulation, everything without the requirement of much complex hardware. So later. So let's assume you are doing a bigger project, or a project in university. So what is next if you have the computational power? So ROS Arduino can only behave as a ROS node because of the limitations inside it. So it has only 32 kilobytes of flash memory and 2 kilobytes of RAM. So it cannot handle much very complex things. So for example, you cannot interface a camera into a Arduino. But if you have a Raspberry Pi, you can easily interface a camera into the Raspberry Pi. And it has 1 GB RAM, and it has micro SD storage. So you can do much more cool things with the Raspberry Pi. So uh, a Raspberry Pi can be installed with Ubuntu and installed with ROS, unlike Arduino. And because of that, because you can install Ubuntu and ROS, you can make it do the role of a ROS master, and it can host multiple ROS nodes as well. So this is a very good way to start a complex project. And as an example, I will tell you something you can do if you have a Raspberry Pi. So this is like example. So this example is like, I am sure every one of you know how a remote control car works, and you 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 have something like that, and you want to connect into an autonomous system. So how you can do that? So this sounds like a very cool a project during your undergrads. And in order to do that, in order to turn this into autonomous, so any sort of a complex system, uh, you can use a Raspberry Pi. So this is an example. So a camera can be mounted into a Raspberry Pi. And when you want to move your robot forward and backwards, you'll need a brushless or brush direct current motor. And in order to control the speed of that, you can use a motor controller from a reputed manufacturer, or you can uh, use other methods to control the speed. And similarly, if you have a servo to do the steering of this car, then you can use a servo controller. And both of these controllers can be plugged into the Raspberry Pi using serial cables, USB serial cables. So if they are if they are from reputed manufacturers like Pololu or something like that, they have already released ROS drivers. So if you want to control using ROS interface or ROS topics, all you have to do is install ROS here, install Ubuntu and ROS in the Raspberry Pi, and then just run the related ROS nodes. So if you run the ROS node to interface motor controller that is given by the manufacturer, then you can easily publish a command topic, and the vehicle will move forward in that commanded velocity. And similarly, if you have a ROS node to control the servo. You can steer like that. And also you can have your ROS node to implement algorithms, whether they are custom algorithms or whether they are like I described before, how you can use ROS navigation stack to do autonomous navigation, and you can easily use all that stack to give commands. And also you already have ROS node to interface camera, so whatever you can see from the camera you can see in your laptop. So how does that work? So this Raspberry Pi usually has a Wi-Fi interface, so if you have a router, you can both connect your laptop and the Raspberry Pi in the same Wi-Fi network. And ROS has a pretty cool feature. ROS can automatically handle communications over wireless mediums, so you don't have to do anything new or do very complex things. If you just SSH into this one, and you can connect these two very easily. And in your laptop you can use RVs for visualization, so you'll see where you are going through this image feed from this camera. It will be passed into the computer through ROS very easily through Wi-Fi network. And you can use teleoperation, you can give teleoperation commands using your keyboard, so you can use your arrow keys to control this car just like you are playing a video game. And you can also use ROS nodes for navigation. So overall, this is a very cool project, and you can do many, you can implement many algorithms, you can test many algorithms in this one. And or maybe you can do machine learning tasks, you can use it to identify the lanes, obstacles, anything like that. And many complex things can be done using a minimal requirement of your hardware. So it might be useful for your projects, anything like that. So so this is a robot that we already have in our university. So this is called a Sumo robot. So this is a differential drive robot. And this differential drive robot is usually has a microcontroller called Atmel A32U4 chip. And it is usually only Arduino compatible, but not ROS compatible. So as we mentioned before, if it is Arduino compatible, then you can install ROS serial library into that one, or into ROS, and add some libraries in Arduino. Then you can convert this robot into a ROS compatible robot. So we also call that as ROS wrapping. So we have ROS wrapped using ROS serial packages. And now this robot has uh, all the capabilities I have mentioned in previous slides. And one cool feature is that it allows us to use visualization tools to verify algorithms before implementing on the real robot. So in this small video, you can see the robot doing a small line following operation, and here in R, which you can visualize that. So even if in the absence of the real robot, you can check your autonomous or any all of your custom algorithms, how they behave in this ROS environment. So that pretty much summarizes everything. And we'll go for the Q&A session. Thank you. So we have some questions.
You can take the last question, Banu.
Okay, can you explain when to use RVis and when to use Gazebo? Of course. So RVis is a visualization tool. So you can use that to visualize how if you have a robot model, then you can use it to visualize. So RVC is a visualization tool only, and it cannot do simulations. So Gazebo is a simulation tool. So the main thing is you can run both of them at the same time. So if you don't, Gazebo is used to do the simulations. So if you don't have the real robot, or if you are testing some algorithms, you can test with Gazebo. As you can test with Gazebo, you can do the visualization along with that in RVis. For example, if you have an arm, the RVis will visualize what are the angles you have commanded and how the robot arm should look like when it is commanded. So Gazebo will do the physics things. It will take into consideration the gravity and all those factors, the torques, gravity, everything, and it will move the actual arm, simulated arm. And if you have the real robot, so you don't need the Gazebo, and then you can interface RVs with the real robot. I hope that explains it. And another question, in an application like self-driving car, is localization done by using GPS? Yeah, yeah. So if you have a reliable GPS source, you can localize yourself using the GPS data. And for example, it is not only the thing. So if you are like using a tunnel or something like that, if you're driving through a tunnel, then you might be not getting GPS data. So in such a scenario, you can use other information. If it is a car, like IMU information and odometry information to localize in the map. And of course, GPS is a very important. GPS plays a very important role in localizing in a given map.
I can add something to that. So we are actually doing finally a project. So that is the localization of a self-driving car. So you can first of all understand the gravity of that problem. So estimating the exact location to a centimeter level is very difficult, because if we are driving a car autonomously, we need that precise vehicle localization. So we, of course, we will use GPS, but GPS can jump here and there, and it is not like centimeter level accurate, or even so there are centimeter level accurate GPSs, but they are very expensive. Therefore, we are actually relying on many sensors. So we will count the number of wheel turns, so that the wheel odometry is there. Then we have an accelerometer sensor, the gyro sensor, so in a compact inertial measurement unit. And we can also see use the cameras to how much distance we have moved in let's say 1 second of time. Likewise, it's we are actually using, or the community, self-driving community is using many sensors, and then only we combine all these to get the localization. So it's not just the GPS.
I can answer the question. Can Arduino receive a Rostopic command through Wi-Fi? Usually, in the example I mentioned before, it is getting the Rostopic commands through the serial interface. But
Yeah,
so
through Bluetooth, right? In our experiments, that one.
in our
Yeah.
Sumo experiment, so if I can show you, so this is a Sumo robot, and we'll be using these Bluetooth modules. So we'll be using this. I'm not sure if you can see. So this is, you can approximate this as a Arduino, and this as the Bluetooth module. Or if you have a Wi-Fi module, it will be like that, and you can connect these two. And after you connect them, you can connect to the Wi-Fi with the ROS master there. And if you are using Bluetooth, that means like the serial communication protocol will still apply, but over wireless medium. And yeah, so can Arduino receive? Yeah, it can be. You cannot use an Arduino itself. You need the Wi-Fi interface and all other things, and you need to install some libraries, and as I mentioned, make it a ROS node. Then afterwards it can take commands through Wi-Fi or Bluetooth or any wireless media. So I think that addresses the question last. So it is not necessary to connect to your Arduino ROS node to the master PC via USB all the time. No, of course not. So it is good to start that way. So I was explaining example of ARM. So it can be widely connected, but if you are doing a like a car project, then you can have wireless interfaces, and it will happen like that,
Yeah,
happen the same.
if I also add something to that last question. Now, I think you already know that using the Arduino itself, we can do a lot of things, right? A lot of, the in the robot competitions, we can make the robot do many things. But here we are actually talking about like integrating some more like additional or like some very interesting algorithms, like let's say if you want to do simultaneous localization and mapping slam kind of thing. So if you want to do that kind of a complex thing, then we can use or we can convert our Arduino robot into a ROS node and get all the help in the ROS community and integrate into that one. So that's what we are actually talking about, because I think sometimes it's like meaningless to make it a ROS node always, right? Because it can do certain things by itself. You have, I think, already done that in competitions. But here we are telling you the possibility of maybe improving or increasing the functionality and understand certain things using a simple Arduino robot.
Should I use wired system or wireless system? That actually depends on uh, what you want to do with your project. So if your project can support, if your project can be handled using wired communication, then you don't need to spend money on your wireless system. But if it cannot be done, for example, like if you are doing a remote autonomous car, then you will have to definitely go for a wireless system, and it actually depends on your requirement. And for the previous question, can we do a demonstration of how to build a node for camera, then run it? I am not
Yeah, are
sure if
we talking about for this workshop? I think that would be a little bit involved, because since this is the introduction to ROS workshop, maybe it's a little bit difficult to set everything up and explain this. So we have actually prepared a little bit a basic hands-on experience to get you running. So assuming you are a beginner to ROS, but maybe we can do that in a future workshop, do let's say a navigation kind of thing. But today I think we will not be able to do that kind of thing, given that we are also using the online ROS version. So if you are ready with your laptops ROS and Ubuntu install, maybe we can think about that, and we are very sorry about that as well. And I think we also answered some questions in the Slido itself due to the time limitations, because now I think we have to stop for the lunch break, and we'll have a 1 hour lunch break.